This video will prepare you to do the water lab in Chem 121 at Tacoma Community College. By the end of this video, you should have an understanding of all of the safety concerns, how to conduct the lab, what the purpose or questions are for the lab, and then finally it will cover cleanup. So first I want to talk about safety. One of the precautions you'll need to be aware of, we are going to use hydrochloric acid, and acids are corrosive to skin and metals, so they can burn you. The acid that we are using is not overly concentrated, but you still want to clean up all spills immediately, use caution, and remember to never heat an acid on the hot plate. You will be using the hot plate for water, but you should not do the acid metal reaction on the hot plate. Finally, you always want to dispose of chemicals in the appropriate container. You will also be using ceramic hot plates, and this surface gets very hot. So you want to inspect the cord, make sure it's in good condition, test your hot plate and stirrer to make sure it functions before you start your experiment, and be very careful with the cord while you are using the hot plate. This will melt on the ceramic surface and you don't want to cause a fire. Finally, you're going to leave it to cool at the end of the lab, but make sure that you unplug it before you leave. Finally, remember that hot glass looks the same as cold glass. You will want to be careful not to have too many extra beakers laying around your hood, not only because it can cause accidents and spills, but also because you do not want to confuse a hot beaker with a cold one. So we will be looking at phase changes today. In water. And so remember that freezing and boiling points are physical properties, and that means transitioning from a solid to a liquid is a physical change. So the solid can melt to liquid, or the liquid can freeze to solid, and then this phase change between liquid and gas, we can have vaporization or condensation. So vaporization is the process of going from liquid to gas, and condensation goes from gas to liquid. Sublimation and deposition are not ones that we will see today. This refers to a solid going directly to a gas, which you may have seen if you've ever played with dry ice. So our first question is, what are the freezing and boiling points of water? So you may think this is a silly question to investigate because you already know the answer, but you might actually not really know the answer. So we are going to create this heating curve and try to determine exactly what the freezing and boiling points of water are in our lab. So the way that you're going to do this is you're going to set up your apparatus, and the other partner will download a template from Canvas and also get some salt. And you're going to start with a beaker of ice below 0 degrees Celsius, so it's very cold. And you're going to record the temperature every 15 seconds. And you have this template available to you on Canvas, so you can download it directly to the lab computer, open it, and then you can enter your temperature data directly into the spreadsheet, and the line on the graph will automatically grow. And so this is called a heating curve or a phase change diagram. It shows the relative temperature over time as the ice heats to water and then water to steam. And we want to think about, what do you think the line is going to look like? Might it look like a straight line? It just raises all at once? Is it going to be more like a little stair step where we have like these slow and then this jump and then another slow increase and then another jump? Or is it going to be more like a curve, like an arc? So hopefully you will have some idea. With your partner, you can talk about what you think it might look like, and then as you make your heating curve, you can try to interpret that. So a few tips. Please use caution when getting your beaker from the freezer. Your hands must be dry and you'll need to handle it carefully because this beaker is below freezing and it is glass, so you want to be careful. The beaker already has a stir bar in it. If you've never used a magnetic stir bar and a stirring plate, you will need to be careful to adjust the speed setting on the stirrer once the ice melts, because what will happen is the little magnet inside your stirrer or hot plate will be spinning, and then that'll cause the stir bar to spin. And once the ice melts, it will likely be up too high and it will start to splatter the liquid outside of the beaker, and that could cause a safety hazard and also a mess. You'll want to make sure that when you put the thermometer in your beaker that it is not touching the sides or bottom of the beaker, because we want the temperature of the liquid or solid that is in the beaker itself and not the glass. And finally, the thermometer and special clamp come from the cart. And so this is what the thermometer clamp looks like. So this is the clamp you will have to use for your thermometer. The ones under your hood are not small enough to grasp the thermometer firmly. So you'll need to get one of these and also a thermometer from the cart. They are not under your hood, and then you'll need to return them to the cart at the end of the lab. So this is a little video showing you overall how the setup will be, and you'll have your hot plate here and your beaker, and notice how the thermometer is in the ice, but it isn't all the way down at the bottom. And then over time, you will let it stir and you will collect all of the data. Once you have collected enough data to where the water is boiling and it is at a consistent temperature for 2 minutes, you will then look and see what happens when we add salt to the water. Now, when we add salt to water that isn't boiling, that is near freezing, what happens is it lowers the freezing point. Probably seen examples of this. Salting the roads helps melt ice. Vodka does not freeze in a normal freezer. Syrup is made from sap that runs through the trees during cold conditions that are below freezing. And the ethylene glycol that is added to this solution here helps your radiator keep from freezing during cold months. And so you are going to add some salt to your beaker of boiling water once that heating curve is made. So this means that before you do anything, you'll need to have some salt ready off to the side. And then once you have hit that steady state for boiling, you will add the salt and continue collecting data in Excel. And then what you'll want to do is try and answer the question, what happens when salt is added to boiling water? Finally, we are going to try and determine the gases that are in water and answer the question, what happens when we boil water? Does it stay fully as water? Does it break down into H2 and O2? Or is it some combination of the two? So here we have an example of liquid water. Here's all our little water molecules all huddled together. And when it starts to boil, then we will have some separation between the molecules. So here's some separation showing here. But as we continue to add more heat, does it cause some of these bonds to break? Do we get hydrogen gas and oxygen gas? How might we test that? Now we are ready to test the composition of the gas in the bubbles in this beaker. So what you're seeing here is a test tube that is full of water, capped with a stopper, which you can also use a paper towel on your thumb to do when you set this up, or you can use this stopper here. And it is inverted in this beaker. And so this video shows how we're trying to get the stopper removed without lifting the test tube out of the beaker, because the idea is we want to trap the gas bubbles that are in here and not fill the test tube with air. What the video is showing is crucible tongs removing the stopper. And so now you're going to take your tube and try to catch the bubbles that are in here. If you have some trouble finding bubbles, you might want to use a small bead so that you can get more bubbles forming near the mouth of the test tube. And then once the test tube is full of gas bubbles from your boiling water, you will lift it straight out of the beaker and immediately put a match under the lip and record what happens in your lab handout. Now we are ready to test how a match reacts with hydrogen gas, which is generated during the reaction between a piece of metal and the acid. What we have here is a strip of magnesium metal bent over the mouth of a test tube that is full of water. A beaker is then turned over on top of this, and then the whole apparatus is upside down. Now we're adding some water to the beaker, and then the HCl is slowly added to the beaker as well. So now the magnesium inside this test tube can react with the acid solution that is surrounding it. So you will start to see some bubbles forming where the magnesium is reacting with the acid, and you may need to gently rock your test tube side to side so that the magnesium can come into contact with acid. But what's really important is that the magnesium reacts mostly inside the test tube, because you want to do the same thing you did before. You want to fill this with gas, lift it straight up out of the beaker, and test the flammability with a match. Once you have completed this, you will have an idea of what happens when hydrogen gas reacts with a flame. So you want to think about and talk to your partner about how this experiment will help you answer this question of, does water break down into hydrogen and oxygen gas when it boils? Now that you have completed the experiment, you want to clean up. This is extremely important because we don't want to create more work for other people, and it is rude to leave a mess for the next class. You will want to follow the instructions to correctly dispose of the acid in the labeled waste jar. You will need to thoroughly wash all glassware with soap and water. You will need to return the items to the cart that did not come from under your hood. This means the beaker that held the ice, the thermometer clamp, and the stir bar. Anything else you used from under your hood, like the test tube, a beaker, if you used a glass stir rod, that all needs to go back under your hood. You'll need to wipe out the weigh boat with a damp paper towel, or you can rinse it and dry it very thoroughly and put that back under your hood. Finally, return any tongs or forceps and thoroughly wipe down your hood with a wet paper towel, dry it, and then wipe it down again.